My name is Rich Petersen. I'm Director of Product Management at SanDisk, which is now a Western Digital brand. We were officially acquired by Western Digital not very long ago. And I'm joined today by Serge Shats, who's an engineering fellow and my longtime colleague. Serge and I were both with FlashSoft, the company, going back as far as about 2010. We were acquired by SanDisk in 2012. And then here in 2016, we became a part of Western Digital. But throughout that progression, we've had the same mission, which is to enable the use of solid-state storage as an intermediate cache to alleviate I/O bottlenecks and I/O blender effects in vSphere environments. And so we're really excited today because, as Stephen mentioned, this is a technology that's been a long time coming. And we're here at VMworld with our GA products on the show floor. They're VMware ready. They are really, it's something people are really talking about, they're really excited about. It's a reality now. And what we want to do is run through a few basic topics, get you familiar with what we're doing, and really make it as interactive as possible. Serge is going to jump up as soon as the questions get too hard for me, which is usually about 30 seconds in. But anyway, let's start off a little bit with the VAIO, the VAIO program, which is something we collaborated with VMware on beginning more than 2 years ago. VAIO stands for the vSphere APIs for I/O filtering. And the basic concept is to provide an API framework that will allow third-party storage data services to work as first-class citizens in a VMware vSphere environment. Okay? This means that these filters allow the intercept of I/O between the virtual machines and the virtual disks in order to perform storage functions that normally you wouldn't expect a third party to be allowed to do in a locked down environment. In the case of the VAIO framework, the first two filters that were officially GA, one was for replication and the other was for caching. And so we were VMware's development partner and design partner in the APIs for caching. Serge led the team that interacted with the VMware developers on a daily basis in the various iterations of that framework, which went GA with ESX 6.0 Update 1, and our product was released with the first update to VAIO, which came out with ESX 6.0 Update 2 in April of this year. So as I said, it's a GA product. We've taken, as you may know, many of the customers of Fusion IO purchased a caching software technology called IO Turbine from Fusion IO. And we're taking all of our FlashSoft and IO Turbine customers, as they migrate to ESX 6, we're taking them to FlashSoft 4.0. Okay? Everybody's migrating free. So we're really bringing a very, very large number of organizations into this new caching architecture based on VMware's API framework. It's really exciting stuff. A couple of things about VAIO. The level of granularity for acceleration is the virtual disk, okay? Of course, you are operating within vSphere using vCenter, using an interface in the web GUI for vCenter to identify specifically which virtual disks you wish to accelerate, and that sets a policy in the SPBM registry for those virtual disks. So we're using vSphere, vCenter, SPBM. We're behaving as a native component of vSphere. It's vSphere that installs the cache into the filter. It's vSphere that manages the versioning of the cache. It's vSphere that will uninstall the cache. So it really is a third-party product, but it's really integrated as a native component. So with that, what I'd like to do is see if you have any questions about VAIO. Or we've been talking about it for a very long time, so I'm happy to move on and talk about what's new. Is everybody nodding along with that? Okay, good. Let's do that. So the second thing, just as a sort of a historical note, well, about 2 years ago, we began to distribute in an OEM relationship with Dell a version of our caching software, specifically for Dell servers that were shipping with direct attached storage. Now, of course, when we're talking about the VAIO-based FlashSoft technology, it's almost always going out over shared storage. But Dell moves a lot of servers that have their disks either attached directly internally or direct attached as an MD array. Now, in those scenarios, we were replacing a previous generation of caching technology. Dell wanted to move to an all-software technology for caching that would enable them to support any type of solid-state device inside the server. They were moving very aggressively toward PCIe NVMe devices, and they wanted to make sure that within all software caching technology, whatever end customer's choice of SSD would be supported. So that's why we introduced what was called the SanDisk DAS cache, which was based on the FlashSoft software and is available on basically all PowerEdge servers today. So those were the two big developments that have taken place over the past couple of years for us in bringing the software to market. That's kind of the business side, and I know we're not here to focus on the business side, but I did want to make you aware of where we are in the market. Now, Serge, we're talking about caching, and there's one thing that I'd like to zero in on. We have a couple of scenarios. One of the scenarios is the capability to cache within the ESX hypervisor, and also the ability, because of course FlashSoft is available as a write-back cache for Windows and Linux and other operating systems, right? For caching in the guest. Do you want to dive into that a little bit? Walk everybody through caching in the guest versus caching in the host?
Yeah, of course. Yeah, first of all, again, if you have any questions, please feel free to interrupt me and ask the questions anytime. It is interesting that FlashSoft that started with Windows, Linux, and after that we extended our platform, set of our platform that we support on ESX. Actually, our bare metal product is very useful for virtualized environment as well. For example, and maybe this is interesting for you to see as a different use cases. If we have two, and we have a customer, real customers, let's say two virtualized servers with set of virtual machines here and here. Let's say in this case it is 6 Exchange servers here and counterpart here for high availability. But high availability and potentially disaster recovery. If you have replication inside inside application level high availability and replication for high availability on the application level, like Exchange, like MS SQL, it is interesting that our software can be inside guest machine, because high availability that we have will be applied on the top of this. You see what I mean? Yes. Replication will be above our software, which is write back, caching inside guest machine. You see? Yes. Yes. Or you have a question?
Let's start with the more basic example. Let's start with maybe the requirement for write-through caching in a Windows environment with cluster shared volumes.
Okay.
We'll go ahead and draw that out, and then we'll talk. One of the key questions that people frequently ask us is, why can't I have write-back caching all the time, everywhere? And the key challenge there is the replication of data. In some scenarios, we can provide write-through caching, but we cannot provide write-back caching because we don't have control over the ability to replicate. In other scenarios where replication is handled appropriately, we can provide write-back caching that would accelerate both read and write operations.
So this is a cluster, and this user mode, this is a kernel. This is SSD. Sorry, I just mix a little bit hardware and software. This is SSD here, in SSD here, internally attached. And the difference is the following. If this is a virtual machine which is running here, it could be virtual appliance, or it could be application, for example, Exchange is running inside. Our software can be inside here, and if you put VMFS on the top of this SSD and gives to this virtual machine additional virtual disk, which is from this SSD, it's additional virtual disk from here that we give to this virtual machine. In this case, this virtual machine can run our software, bare metal software, inside, having write back here, or write back or write through here. Of course, it could be let's say shared storage here, it could be vSAN, or it could be even, as I said, different data centers with network interconnect. So what I meant in my first example, why it is interesting to see our software inside virtual machine. If you have application that can replicate data for high availability from here to here, you may have, this is active, and this is VM passive. So you can replicate from here to here, and you may have our software here and here, an additional virtual disk here and here, that we use for acceleration for this virtual machine being inside virtual machine. And this is the idea of being inside virtual machine. When we're talking about our VIO product works like as following. Let's say it's a virtual machine, and we want to accelerate this virtual machine. As a part of VIO, I/O filter runs as a part of VMX. It is we're running in user mode. It is kind of library that you use in user mode. And when virtual machine, let's say it's another virtual machine, issued I/O, it goes to VIO framework. It's a framework. And this I/O bounces from here and goes to our I/O filter if we're registered as a I/O filter for specific virtual disk. That's what Rich mentioned. The granularity is a virtual disk. And after that, we do our magic here, caching magic here. We access directly to SSD, so we have all metadata management here without details. So we use daemon, but all events that VIO provides for I/O filter actually will go here in our I/O filter, which is running inside VMX. And it could be, as Rich mentioned, there is a several stack of I/O filters. Replication filter, caching filter, in this order, by the way. It's interesting, actually, that we can talk about integration of these filters, and we talked to Recovery Point about this potential integration, which is very interesting as well. It will accelerate performance dramatically for data centers that use replication for DR. But again, there is two ways of acceleration in virtualized environment: inside guest or virtual appliance, which is another type of guest, or outside of guest, being inside but outside is a part of VMX. This is a VIO design. So we have just second part of our presentation, and we will see how it works together and why it makes sense to use it together, separately, or together. Mm-hmm. Again, back to my first example of use case. If you have MS SQL here, and replication from MS SQL always on, it calls always on, right? You know about it. Replication here to here, which is a virtual machine, we can be here, and write back caching inside guest machine is perfectly fine, because replication is above us. So you see, if replication is above caching software, which is running in write back caching mode, it is perfectly fine. If it is vice versa, it's not fine. It is not fine because as a part of write back cache, actually we change the order and even the number of write commands that we push on an underlying storage, which is a reason for write back caching. We change the order for coalescing, write cancellation, and so on. So you will see today many different use cases of using our software in different combinations in virtualized world. It's just one of them.
Yeah, it's a really good point. One of the things that, one of the conversations that we are having this year, I think very commonly on the floor, is we're working with a number of existing customers using bare metal Windows Server. They have taken on the idea of caching in a big way. They're using caching often for the acceleration of I/O for SQL Server deployments, and they're coming to us and saying, okay, my boss has told me that we're moving SQL Server deployments onto virtual machines running on top of VMware, and what should I do? And the answer is, it depends. It really depends. You could be doing write-through caching on the ESX host, which has the advantage of accelerating every VM on that host, or you could be doing write-back caching within the guest, and which has the advantage of providing write-back. But again, you have more instantiations and it's more administration. But both are viable solutions. And this comes down to the fact that our caching, core caching engine has been ported across so many different operating systems. It's available, obviously, Windows from 2008 up through 2016.
All Linuxes.
CentOS, SLES, Ubuntu,
Yeah.
and of course VMware 6.0.